Our third theorem uses something called an included side. So an included side is the side in between two consecutive angles. So on here, my included side is PQ, and it's included between the two angles of P and Q. So it's still in the middle. So the theorem that relates to this is angle side angle congruence, where if you can prove that two consecutive angles are congruent and the line in between the consecutive angles or the included line are congruent, then you can use angle side angle or ASA congruence. So here's an example of when you could use ASA. So what you have here are two parallel lines and a transversal. I like to draw these out so you can really see the relationship. So when you look at these, you can start to see your what's it called? Oh my gosh, y'all. I'm blanking on the name. Your transversal, your alternate interior angles. So from looking here, I can go ahead and say that angle LNM is congruent to angle KLN because they're alternate interior angles. Looking at the other side, we can go ahead and also say that angle KNL is congruent to angle NLM because of the same thing. So I have my two angles marked. So what I care about is this line that's in between those angles. On the triangle, though, what we can see is that line is shared. So I can say that LN is congruent to LN. Sorry, this is hideous. I should never write with yellow. We use the reflexive property for that. So I have two angles and an included line. So this is angle side angle congruence.